This next topic will be discussing using InfoArchive for application decommissioning, specifically using the table archiving method. Knowing when to position application decommissioning over SIP-based archiving will help speed up the sales cycle. Let's go over some of the main driving factors. Customers moving to new platforms or to the cloud usually only allow for a small set of active data to be migrated. This is a great candidate for InfoArchive. Other customers generally looking to lower their current system operating costs of legacy systems can be a key driver. Risk of losing data due to failing systems or lack of security. Legal requirements will almost always be one of the main driving factors. You can think of old systems without the ability to apply a legal hold or retention policies in any kind. Legacy applications often do not have a defensible deletion process or any ability to easily provide data during an e-discovery initiative. Finally, adoption of new ERP systems, SAP, or CMS can cause a large amount of data and systems to be orphaned. InfoArchive can address any application type with any data structure. We will set up an archive and factory to minimize the cost and make this repeatable. This creates an extremely fast time to value while ensuring you have a fully compliant archive. InfoArchive becomes a central compliant archive across the entire enterprise. Once the legacy applications are in read-only mode, the data can be ingested into the archive. This is the same model for SIP ingestion or table-based. All of the data resides in the same archive. We see the benefit of the table method from the time to value. Targeting data-rich applications, you can use a straightforward process using and reusing your existing ETL tools. This greatly reduces the application analysis. However, because we're not being selective of the type of records ingested, there will be some limited reusability to the actual data ingested. This illustrates our table method compared to the others, focusing on the structured data. The ETL process will go directly from the source application into InfoArchive. The other methods require a SIP package and further processing during ingestion. Our target applications for this method will be mostly transaction type systems, applications with high volumes of structured data, such as Oracle, SAP, Siebel, or PeopleSoft-based applications. Our table-based method of archiving does allow for unstructured content attached to any of these applications as well. So if there is some unstructured attached to Oracle or sitting in a blob somewhere in the database, we can ingest that through this method as well. Application decommissioning using the table method does require some knowledge of XQuery to query the data properly. This learning curve exists, but it enables some very flexible and powerful queries to be written from the developers. Nothing is predefined, so the developers have the freedom to write and execute the queries as needed. The search forms created in the UI will relate to records returned by the queries written. Since the form widgets result columns and the data bindings handle the variables returned from the query, they need to be taken into careful consideration when developing. XQuery itself is easy to learn and construct. One clear advantage of using XQuery is its extreme flexibility. Since the tables are ingested prior to writing the queries, a developer can optimize or rewrite the queries as needed. This allows for new functions, joins, or data manipulation to occur post-ingestion. When creating your application, you will be able to select the type of the archive. In this scenario, we can select based on table schema. To an end user searching, they would never know whether the records are stored in tables or packages. The schema of the XML represents the schema of the tables. All records in one table are stored as one or many XML files. This provides the ability to separate very large tables into smaller, easy-to-handle files. For example, we append 0001 to the end of this XML file, which might be the first of many loads. The structure of the XMLs need to be the image as shown. The application name being the root element, with the table name as a child element, followed by the records as repeating row elements. For example, the application name is order management, and the table is suppliers. We do still need to declare the table schemas in an XML format also. InfoArchive is schema agnostic, which is huge, but keep in mind that we still need to describe the schema. This is the metadata file shown here. This will describe what fields exist and the types of those fields. The metadata file also includes index flags and whether we want to encrypt that field. If you want to encrypt the specific fields, be sure to include the flag in the application build file also. The build table.xml file will create the crypto objects for us. This section does not normally need to be altered, but you should know it exists. When you have flagged an element to be indexed, an index task will be triggered and create a multipath index for that field. The index will be created at the end of the ingestion process. This is also described in the build table XML file. To summarize, the search designer needs to understand xQuery and how it relates to the search form elements. Developers can use tools such as xdbadmin or any other xQuery client to test queries outside of the InfoArchive UI. If there are any mistakes made causing improper bindings to elements, error messages will be displayed during the search execution in the UI. The table method allows archiving with little upfront analysis. Basically, dump and load the application data. Typically, the search screens created in InfoArchive will reflect the source application very closely. The flexible design allows for multiple tables to be queried, although the impact on performance should be considered. Also note that just because we've been focusing on tables, unstructured content can be stored as a blob in XDB, but we do recommend storing this on the storage tier for production.